Today I'm going to show you how to hand disassemble the JEDEC file of a GAL 16 V8. I'm working behind the camera here and going to be writing at the same time, so be patient with me. This is going to take a while. Now, JEDEC stands for Joint Electron Device Engineering Council. They're the folks that come up with this standard of ones and zeros for the GAL or PAL. GAL stands for Generic Array Logic, and PAL stands for Programmable Array Logic. Now, when we're hand disassembling the ones and zeros into a logic equation, we need this matrix right here, this array, and you can get this array from the data sheet. And the data sheets for these GALs and PALs are all over the internet. On the JEDEC file itself, we have a row of ones and zeros, a second row of ones and zeros here, and then down here more ones and zeros, and on down throughout the JEDEC file. Now, this JEDEC file has 2 pages. There's the second page right there. When we're reading the first line from left to right, we're only concerned with the zeros. And the first line, the complete first line, is ORed with the complete second line. This will be clear when we get done with our equation. So, let me hold this. I'm trying to work around this tripod here. So, let's grab the first zero. This is at position within the array at 0, 0, 0, 0, 0. That's its position. So we go over here to our array diagram and we follow position 0 all the way down until we bump into a dot. And that dot leads over to a buffer. The buffer has 2 different outputs. One would be active high, no bubble. The other one would be active low with the bubble. So we follow that first line down until we bump into this black dot and follow it over, and that's input pin 2. And because it's non-inverted on the output side of this buffer, that means that this input pin 2 is active high. So let's write that over here. I for in 2. In 2. Let's go over here to the next 0. It's at position 0, 1, 2, 3. Okay. We go over here and we find that line 0, 1, 2, 3. And you follow that line all the way down until you bump into a black dot. 0, 1, 2, 3. It goes to this. Let's follow that over. Now the buffer's inverted. We hit a bubble on that buffer. Let's follow that input of the buffer all the way around here to pin 1. Okay, so this is an AND. Let's put the AND symbol right there. A dot is the AND symbol. That's pin 1 in pin 1. Put a bar over it indicating that it needs to be active low. So far, to make pin 19 activate, we know that pin 2 needs to be high and pin 1 needs to be low. Okay. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It is 12, not 11. It's 12. So let's follow 12 down. And we hit this dot right here. Let's follow it over. It's on the high side of that buffer on the output side, and that's pin 5. So AND in 5 is active high. I'm reaching way over here to write, so my writing's going to be a little bit sloppy. So this one was 12, 13, 14, 15, 16, 17 is the next 0. We're only worried about the zeros, so that's 17. Let's follow, there's 16, let's follow 17 down until we hit a dot. And it goes way down here. I don't know if you're in the camera. Follow that dot over, and it goes to the inverting output of pin 6. So AND, put our dot there, in 6 bar. I'm about to run off the page. So far, to make pin 19 go active, we need pin 2 to be high, pin 1 to be low, pin 5 to be high, and pin 6 to be low. So we've got one more. We know this is 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. There's 28, 29, 30. And I'm going to run off on down here, and it hits, let me move the camera down so you can see, it hits this dot right here, and this dot is on the non-inverting output of that buffer of pin 11. So pin 11 needs to be high. Let's move back up to our writing. In 11 needs to be high. Okay, so to make pin 19 go active, to change states, pin 2 needs to be high, pin 1 needs to be low, pin 5 needs to be high, pin 6 needs to be low, and pin 11 needs to be high. Okay, now we're not done yet because we have an OR line here. This is ORed, the second line here is ORed with the first line. So it would be this and this and this and this and this, or this and this and this and this and this. So we need to OR the second line. Let me make a little line down here. I'm left-handed, trying to draw way over there on the right-hand side. Let's put our plus sign to indicate OR. These dots indicate and the plus sign indicates OR. Okay. So let's do the second line of ANDs. Okay, so this 0 here is underneath that one, and we've already done this one, so we know that that has to be in 2. 0. We'll do the next one. 0, 1, 2, 3. Position 3 is under that one. We've already done that one. So that one is this one up here, and that is in pin 1 bar. Okay. Let's do the next one. Right beside it. 0, 1, 2, 3, 4. This is a new one. Let's follow 4 down until we bump into a dot. Okay, 4 bumps into this dot, and that's on the non-inverting output of that buffer for pin 3. So in this case, pin 3 needs to be high. And 3. Okay, let's find the next one. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Look at that. Position 12 in the array is underneath that one we've already done. And that was in 5. Okay. There's only one more. And that's at position 30, and we've already done that one. That's at in 11. Look at that. Now that's for pin 19. Up here's 19. This one down here is pin 18. This one's here is 17. This one's 16, and so on. And you can tell which pin this one is for by following it back. Here you got 0 to 224 is for pin 19. All of these ANDs and ORs are associated with that pin. There's 0 to 224. Pin 18 is from 256 to 480. There's 256. There's 480. And so on down throughout the array. So here we have 2 lines that we just hand disassembled. To make pin 19 go active, input pin 2 and input pin 1 low, and input 5 and input 6 low and input 11, or input pin 2 and input pin 1 low and input 3 and input 5 and input 11. So this is our first set of ANDs ORed with our second set of ANDs. And you continue on down and do the rest of the pins, and you will have completely hand disassembled the JEDEC file. Now you'd be wondering, what are these other zeros down here? Well, all of those zeros correspond here, and you can ignore those. They're going to turn on that input AND gate, that one, and that one, and that one. So you can ignore all these. There's no need to follow those out. It's only these ones up here that have the zeros and ones. And you ignore the ones, you're only worried about the zeros that correlate to the equation. I've seen JEDEC files that had ones and zeros through all 8 inputs to that function right there for pin 19. So you would have ones and zeros through all 8 of those ANDed parts. So it would be this line, or this line, or this line, or this line, or this line, and all the way down. There's a lot of versatility in this chip. Hope you enjoyed that. That was a lot of fun. We jumped into the deep end of the pool on that one, didn't we? Now the next video, I'm going to show you how to determine the configuration of that gal, whether it be registered outputs, complex outputs, or simple outputs, and whether these outputs will be active high or active low. I'll do that video tomorrow. It's getting dark around here. Got to get up and go to work soon. Thank you very much for watching. As I said before, that was a lot of fun.